So my name is David Verhoeven. I'm in veterinary microbiology and preventative medicine. So today we'll cover some of our research involving the development of a universal flu vaccine that we're developing for humans as well as production animals. A little bit about us. So we're mainly focused on respiratory immunology and vaccinology, although we also do some respiratory bacteriology as well. We have multiple different vaccines in testing phases for both human and production animals. We are particularly focused on baculovirus production of protein for various different vaccines. We also have some mammalian protein production. And then we've been working quite extensively lately on some new mRNA technology that we're hoping to get disclosed and patented through ISU. That's very different than some of the things that are prior licensed. So today we'll cover some of our flu vaccine stuff. So flu is a significant virus, although given with COVID this past year, flu was not such a big thing for humans. Nonetheless, flu remains a pretty big deal for particularly poultry, as well as the swine industry. So there's a lot of different flu viruses that occur. So humans, it's seasonal, but in swine, it's continuously circulating, and it causes quite a bit of economic loss in the swine industry. And when there's high-path flu outbreaks, it can be significantly damaging. Such outbreaks have occurred in states like Tennessee, as well as Iowa, that necessitated large culls. So vaccination remains the biggest way to prevent flu. So back in the 2009 outbreak of the pandemic, H1N1, that came out of Mexico and started circulating through the US, some of my colleagues were curious of whether horses were also getting H1N1 because we saw similar type of things in some of the other domestic animals like cats. And so they started to screen cats, they started to screen horses, and they didn't see infections in horses, but they sent some of the serum out to collaborators, Richard Webby at St. Jude, and he screened a bunch of antibody responses across multiple different seasonal strains. And surprisingly, what we found, and you can see that in this slide here, is that there's this great cross-reactivity of antibodies across multiple seasonal flu strains, human, as well as some of the potential high-path flu strains, such as the H5N1 or H9 or H7. So that is total antibody responses. So functionality, we also see that horses had a significant amount of cross-reactive neutralizing antibodies, either as shown here with the HAI or microneutralization. And so that was very, very surprising to us in that horses that are vaccinated with equine H3N8 appear to elicit this broad immunity across the board. So then we started to vaccinate mice with H3N8, either the whole virus or now with recombinant HA based on that H3N8. And we see the same sort of cross-reactivity in the mice. It's broad antibody responses across the board. We don't see a similar trend whether we vaccinate with H1N1 or H3N2, the typical human seasonal strains. Just like the horses, we also see across the board when we vaccinate with the H3N8, this great neutralizing antibody responses in mice. So it very much mirrors what we see in horses. And so we were very, very excited that this could be a potential universal flu vaccine. So we started collaborating and we started looking at how the antibody responses might be protecting. And so we did a comparison, and you can see that on the left here, of our serum against some of the main broadly neutralizing antibodies. And we can see that we can react significantly across multiple different strains. Most high comparison is the CR9114, which is a stem binding neutralizing antibody. We started looking at specifically the serum, and we could see that there's at least 3 neutralization spots when we do competition assays with characterized broadly neutralizing antibodies. And so rather than our immunogen just targeting the stem, we have 3 different locations that the antibodies are targeting. And so escape variants will be much more difficult with our vaccine than some of the universal flu vaccines that are targeting mainly the stem. We started doing some challenge studies, and we see that mice, as shown in this slide here, with a lethal H1N1 or other H3N2s or even other H1N1s, the mice are completely protected from lethal challenge. And so we get this broad antibody response that is protecting mice. Mice are one thing. Ferrets are probably the better proof of the pudding. And so we started to vaccinate ferrets with our immunogens, either the whole H3N8 or recombinant trimeric HA based on it. And we also saw broad neutralizing antibody responses in the ferrets. When we challenged those, you can see down in here in the bottom that the H3N8, whether it's the protein or it's the vaccine, we don't see virus as compared to like the H3N2 control vaccination. So just like the mice, the ferrets are well protected from challenge when we give them this vaccination with the H3N8 HA. We've then extended this now into swine and poultry, and we see very similar trends in experimentally infected animals. So one thing that would be interesting is that we have filed for a patent, and you can see that's the current status of our patent for this immunogen as a universal flu vaccine across multiple different species. And so we're filed that back in 2016, and we're waiting, hopefully, that patent will come through. So one of the next things that we're doing is that we're working with the Nano Vaccine, and we're taking our recombinant HA and we're putting in nanoparticles for further development to humans. We're also taking some of those nanoparticles and we can put them into our what we call rods or nanorods. And we've been testing that now whether we can vaccinate eggs. So we take 8 embryonated eggs, we can put our rod that slowly erodes and releases our HA. And you can see that down at the bottom that our rod releases the HA and it transfects cells that are on top of that. And so it's a way to deliver this immunogen within the eggs. And when chickens are hatched, we can actually see a broad response similar to some of the mammalian species that I showed you earlier. And they're neutralizing any responses to multiple different flu strains is much more accelerated if we inject that in the eggs. And so they come out immune when they hatch. So one of the things we're looking for now is we're looking for collaboration partners, particularly for testing our swine, or our universal flu in swine for possible licensure. We also have, as I mentioned in the second slide, we have other technology for PERS and PEDV as a combination, as an implantable vaccine that we'd be very interested in testing in swine. Further development of either the flu or other vaccines for poultry are also very interesting. We have other collaborations with other industry partners where we're making baculovirus protein vaccines for them as well. So we have large 10-liter bioreactors, and we're very well versed in making proteins and baculovirus. We're, of course, always can entertain venture capital as we spin off potentially a vaccine or work with industry partners. And if you're very interested in our mRNA vaccine, then we'd be very interested in MTA, and we can discuss that further. Again, we can make our mRNA vaccines much more cheaper than Moderna or Pfizer or other companies. And they work very, very well. And it's not the same as what Moderna and Pfizer have patented. It's a different technology that we hope will advance the field, particularly for production animals.